Alright, now children, we move to the next topic, sign convention for heat, and along with this sign convention we even derive the expression of work done by the system. Okay, so to understand this one, as you know, heat can flow from a body at higher temperature to a body at low temperature. That means heat flow or heat will transfer only when there is a difference in temperature. Okay, now if there is a system of body, if there is a system of what body, okay, if there is a system bounded by the surrounding, bounded by the what surrounding, and you know heat will transfer only from when there is a difference in temperature between the system and the surrounding. Okay, but this transport heat, as per the sign convention to be followed, can take place when heat is given from a system to the surrounding. When heat is given from system to the surrounding means heat which flow from system to the surrounding. Means if the system withdraw the heat, or we taken out the heat and give it to the surrounding, then the heat is taken with negative sign. The heat will taken at what sign? Negative sign. Means when heat is taken as negative sign when the heat given by the system to the surrounding. That means when system gives some amount of heat to the surrounding or withdraws some amount of heat to the surrounding, okay, then that heat which is taken out is always as negative sign. That's why the heat is taken with what sign? Negative sign. But the reverse process is also correct, true. That is, when heat is taken from surrounding by the system, if the heat system absorbs some amount of heat from the surrounding, and this heat which absorbed by system from surrounding also takes place with the temperature difference between system and surrounding, and in this case what happened? It flows from surrounding to the system. Means in case of system absorbs some amount of heat from the surrounding, then that heat is taken with positive sign. So absorption of heat, simple way I'll tell you, absorption of heat is taken as positive, rejection of heat from system to surrounding is taken as what? Negative. So heat sign convention for heat is very important, children, and this part makes you sure that the absorption of heat by the system from the surrounding is always positive, whereas rejection of heat from the system to the surrounding is always taken as what? Negative. This is the sign convention for heat. Okay, now we go to the next, that is expression of work done by the system. Expression of work done by the system. Now, in order to derive the expression of work done by the system, and this system also known as thermodynamic system, because thermodynamic system is those system, okay, which is comprises by the thermodynamic coordinates like pressure, volume, temperature, and all. Okay. Now, for that, let me just consider a cylinder. Let me just take a cylinder. Okay. Let me draw a diagram out here first. Let me take a cylinder. Okay. This is a cylinder. Okay, now this cylinder is fitted with a movable piston. So there is a movable piston. Okay, so let me draw out here. This is a what piston? Movable piston. And inside the piston, what is there? The gas is present. So there is a gas. Now this gas acts as a what system? Children, this gas as a what system? Now this cylindrical vessel act as a surrounding, and there is a movable piston. These are what? Movable piston. Okay. Now this gas we can consider as a system, as I said, and we consider what type of gas as this gas? Ideal gas. Now not a real gas. Now you understand in detail in one of the chapter called kinetic theory of gas about the ideal gas, but let me just tell you that the gas which actually follow Boyle's law, Charles' law, gas equation are called ideal gas. Like it can be oxygen, it can be hydrogen, it can be any gas. Okay, but the gas which actually follow a gas equation or gas laws are called ideal gas equation. Ideal gas. Okay, and we are considering what gas? Ideal gas. And that is contained in a cylinder fitted with a movable piston. So this is a movable piston. Okay. Now some weight are already placed on the piston. Okay, some weights are already placed on the what? Piston. So let me just take, there's some amount of weight that's already placed on the piston. Okay, so some weights are already placed on the what? Piston. Now the next part that you need to keep in mind is that this bottom, the bottom of the piston okay, is basically made up of what? Some conducting material. So bottom is majorly made up of some conducting what? Material. Okay. Now when it is made up of some conducting material, so that the heat can flow in and out through this what? Conducting material. Okay. Now the next one is when the piston is placed, okay, with some weight, okay, there is some volume or pressure exerted by this gas as a system. Okay, some volume and pressure exerted by this gas inside the what? Cylindrical fitted cylinder. Okay. Now if we remove the weight from the piston, if I remove some weight from the piston, okay, then what happen? This gas will expand. This gas will expand, okay, by doing some work against the piston. Means the gas, there is expansion of volume of this gas, okay, and this volume expansion which takes place inside the cylinder, okay, is due to the work which is done against the piston. So on removing the weight from the mobile piston, okay, the gas will expand, so that work is done by the gas against the piston. So children, under this case, what happened? The work is done by this gas on the piston. So that when the work is done by the gas on the piston, this piston simply move up. So there is a displacement of the piston. But on the other hand, if you put some weight, if you add some weight, additional weight on this piston, then what happened? The gas get compressed. So gas get compressed means there is a compression of the what? Gas. Okay. So by adding some additional weight on the piston, the gas will simply get compressed. Under that case, what happened? The work will be done on the gas. So work will be done on the gas by adding some weight on the piston. Okay. Work will be done by the gas by removing some weight from the piston, which means this gas, as I said, as a system, means do the work, or it will be work is done on the system and work is done by the system, and that is all depend upon the removing of weight from the piston and adding some weight, additional weight on the piston. Now in order to derive the expression of work done by the system, children, let me just consider that this gas acquire pressure, and this pressure is called initial pressure. So I write down, let P be the what pressure? Initial pressure. I write down initial what? Pressure. Initial what? Pressure, okay, of a gas. Initial pressure of a what? Gas. But this gas is comprises in a piston of certain area cross section, and that area cross section I write down as A. So I'm just denoting by the letter A as the what? As the area of cross section. This is the area of what? Cross section. Okay, I'm writing out a area of cross section of the piston. Area of cross section of the what? Piston. So if this is the pressure and this is the area of cross section, then we can calculate the force exerted by the gas on the piston. Now I write down the force exerted by the gas. Gas means the system, okay, on the piston, and this force which is exerted by the gas on the piston is simply given by F, and you know F is the symbol we use for force, and this force equals to pressure into area, because pressure means force by area. You have learned it already, children. Pressure means force by area, that we have learned it already. So that force means pressure into area. Now I am taking this case of force exerted by the gas on the piston is due to the weight which I remove from the piston. So if I remove the weight, then this piston will move up due to the expansion of gas. And let me just consider that the new position of piston occur by under the gas expansion of gas will be this one. So this dotted portion, so that the piston will move from this position, initial position, to final position, so that there is a displacement of this piston, and this displacement I consider as ds. See, ds is very, very small displacement, okay, that is the displacement of piston from initial to final position, that is exerted by the force exerted by the gas on the piston. Okay, so I write down again, let ds be the what? Displacement. This is the displacement of the piston. But as I said already, this displacement is very, very small, okay, due to which also there is, due to which the force is exerted by the gas and the gas get expand, okay. So under this case, what happened? The work is done by the gas. The work is done by the gas or by the system, and that work done is also very small. And this ds is also called infinitesimally displacement. I am using the word infinitesimally small displacement. Small displacement, a very small displacement which tends to 0 but not equals to 0. So that is called small displacement. But even with this small displacement, okay, which is produced by this force, work is done by the gas. So I write down therefore work done by the what? Gas. And outer gas is a what? System. Gas is a what? System. And this work done is given by dW. And this work done is also very small. Very small work done. And but work done means what? Force into displacement. And that displacement is theta s, ds. Now this work done which equals force in displacement occurs because force is exerting by the gas. In direction of force, only displacement produces. Displacement produces in the direction of force. That's why work done is given by F into ds. But what is F? See F, we have already calculated. So let me just put out here P into A. Okay, P into A, and there is what? ds. Okay, P into A into what? ds. Now I write down this as P A into ds. P A into ds. So this is area and this is a displacement. And you know area into displacement means a volume. And this volume is also very small volume. Okay, that is expanded by the gas. The volume, increase in volume of the gas. And due to this small work done. So when there is a small work done by the gas, there is a very small change in volume of the gas, and that volume is given by dB. So children, remember this, dB equals to AdS, a very small volume or increase in volume of the what? Gas. So I can write now this as dW equals to PdB. So P and this I replace by dB. So very small amount of work done by the gas is equals to PdB. Now children, with this small work done, we calculate the total work done to increase the volume of the gas. Okay, say from initial volume to final volume. And I consider that initial volume is B1. Suppose the gas volume increases from B1, this is initial volume, to say final volume, that is B2. Even to increase the volume from B1 to B2, you have to do the work done. And work done, okay, by the gas or system, okay, to increase the volume from B1 to B2, that is from initial volume to final volume, can be done, calculated by integrating this equation. Let me just give this as equation 1. See, I am using the word integration because integration means the addition. So if you add all the work done, small work done, to increase the volume from B1 to B2, that gives the total work done to increase the volume from B1 to B2. And that is given by integrating this equation. And integration means this sign, dW. This is the sign of integration, equals to integration of PdB. But you know, on the right hand side, your volume is changing from B1 to B2. So from initial volume B1 to final volume B2. And in the case of integration, this B1 is also called lower limit. This is called lower limit. And this final volume is also called what limit? Upper limit. So children, out here also we have calculus. So we need to use what? Calculus. So in this integration, okay, I consider that while there is an increase in volume, the pressure remain constant. Pressure remain what? Constant. So I write down at constant pressure. At constant what? Pressure. If the pressure of the gas remain constant, then due to the work done, total work done, the volume changes from B1 to B2. So that I write down integration of dW is equals to P integration of B1 to B2 dB. And children, anything in the integration which is constant, you can take out from the integration. So that's why pressure I have taken out from the integration, because this is constant. Okay, now I do integrate this quantity only. So in calculus, children, you have learned a formula, that is integration of dx is x. Again I repeat, integration of dx, where x is the variable, integration of dx is always x. I follow exactly same. Integration of dw means w. P, integration of dB means b, but there is a limit, so I put bracket B2 upper limit and B1 lower limit. So after doing integration of dB of B, you have to substitute, you have to expand it by putting B as upper limit minus B1 as lower limit, which means I write down W equals to P, B means B2 upper limit minus B means B1 lower limit. Now this is a work done by the gas. Now this is work done by the system of gas at constant pressure. So this work done by the gas at constant pressure is given by W equals to P bracket B2 minus what? B1. So children, one point you need to keep in mind out here, that this relation measures the work done by the system. Okay, but if the volume of the system increases, this is the increase in volume. This is actually the increase in what? Volume. If the volume of the system increases, then this work done by the system, work is always done by the system and is always taken as what? Positive. Means when work done by the system, when work done become positive, when work is done by the system. When work is done by the system, when there is an increase in what? Volume. But if the volume of the system decreases, when there is a compression of gas, then the work is done on the system. And when work is done on the system, that work done is always taken as what? Negative. So this work is positive when there is an increase in volume, so that this work is done by the system, and this work will be negative when there is a decrease in volume and the work is done on the system. So work can be done on the system, work is done by the system. But when work is done by the system, that work done is positive. When work is done on the system, that work done is what? Negative. But this is the expression of work done by the system at constant pressure. So this is the concept of work done by the pressure, work done by the system. Now in the next YouTube video, you learn about the concept of internal energy.